All right, so as promised, I'm going to do a residual problem. What a residual does is it basically measures how far away a data point is from the trend line. So if I told you that this equation right over here was the trend line that modeled this particular data, we could use this trend line and that data to find the residual. So just so that you guys know, a residual, let me type it out. So a residual is equivalent to the actual y value obtained from the data table. So in this case, 5, 6, 10, 12, and 12, minus the predicted y value. And we get that from using the trend line. So I'm actually going to change the colors of these just so you can see actual minus predicted. Okay, and I put those in red and blue for a particular reason. I'm going to move this equation right up here, and I will begin. So, again, the 5 is the actual data that was obtained when x equals 1. But if I evaluate the blue function for when f of x is 1, so f of 1, that's equivalent to 2 times 1 plus 3, which is equal to 2 plus 3, or 5. So actually, the predicted y value is the same when x is 1. Let's check for when x is 2. When x is 2, then the predicted y value would be 2 times 2 plus 3, or 4 plus 3, which equals 7. So it's a little bit off, not too much. Let's try for f of 3. When the function is 3, that's 2 times 3, which is 6, plus 3, which is 9. So 6 plus 3 should equal 9. We got 10, so that's 1 off. Again, pretty close. When we have f of 4, right, that's 2 times 4, which is 8, and 8 plus 3 is 11. And then finally, f of 5, 2 times 5 is 10, and 10 plus 3 is equal to 13. So the red is the actual, the blue is the predicted, and so to find the residual, we just take the actual minus the predicted. So 5 minus 5, that's 0. 6 minus 7, that's negative 1. 10 minus 9, that's 1. 12 minus 11, that's 1. 12 minus 13, that's negative 1. So these here are the values I would put in as my residuals when x equals 1, 2, 3, 4, and 5.